1.1, interior and exterior angles. This is the first section for Unit 2.5. I kind of split up Unit 2 into two smaller units, so that's why it's not syncing up perfectly with the book. We're going to spend this chapter 7 and chapter 8, and we're going to call that a separate unit. So we're in Unit 2.5. The first thing we need to know is triangles. How many degrees are in a triangle? Hopefully you said 180, or at least thought 180, because that's how many degrees are in a triangle. And that's the triangle sum theorem. You need to know that. It's hopefully you've been doing stuff like that before, where you've been given two of the angles, you have to figure out the third, that type of thing. So the sum of the angles of a triangle is 180. Cool, we're good with that. What about a larger shape? What about a quadrilateral, a shape with 4 sides? Well, we know there's 180 degrees in a triangle for the inside angles, right? How many triangles does it take to make a quadrilateral? How many triangles in a square? How many triangles in a rectangle? Well, we can map that out real quick. Wow, we can Now we can clearly see there's 2 triangles here, right? There's one here and there's one here. So there's 180 degrees over here total. There's 180 degrees over here total. So I wonder how many degrees are in that guy. Similarly, what about this pentagon? How many triangles does it take to make a pentagon? How many triangles does it take to make a hexagon? How many triangles does it take to make a 7-gon, whatever that's called? Hopefully you figured this one out by now. It takes 5. So what's the pattern here? What's going on? So a figure with 3 sides, we call it a triangle. It takes only 1 triangle, it's 180 degrees. A figure with 4 sides takes 2 triangles, that's 360 degrees. A figure with 5 sides is a pentagon. How many triangles does it take? It takes 3. So therefore, how many degrees is inside that pentagon? Well, it's 180 times 3, because there's 3 triangles in it. So it's 3 times 180. We carry the 1, that's 540. Cool, a hexagon, it has 6 sides, made up of 4 triangles. So we do 4 times 180, that's 720. A decagon, we'll jump right ahead to 10. How many triangles make up a decagon? Even without looking at it, I should be able to figure out the pattern here, right? How are these numbers related? Well, hopefully you've noticed that it's 2 less. So I'm going to put 8 here. That means we do it 8 times 180. What's 8 times 180? It's 1440. Cool. So hopefully by now you figured out the pattern, and that pattern is our polygon angle sum theorem. It says the sum of the measures of the interior angles of a convex polygon with n sides, right? So n being a 5-sided figure like a pentagon, or a 6-sided figure like a hexagon, is n minus 2, right? That's what we did here. We took n, we subtracted 2, and then we multiplied that by 180. n minus 2 times 180. Cool. So here's an example in your book. Here's a big nonagon, 9-sided, and it asks us to find this angle x. So we use the polygon angle sum theorem to find out, okay, if it's a 9-sided figure, how many degrees are there supposed to be for the interior angles? So we take the 9, we subtract 2, that gives us 7. We multiply the 7 by 180, and that gives us 1260. So we know it should add up to 1260, or it will add up to 1260. And then it gives us all the other angles, so therefore we can just subtract all the other angles, or the sum of all the other angles, to find x. I'm not sure what all the other angles equal, but we subtract that off, we get 158. Right? These are things that you can use a calculator for. Don't expect you to do that in your head. Okay, we'll do one more example here. Let's try part B. It says determine the unknown interior angle sum angle measure of a convex octagon in which the measures of the other 7 angles have a sum of 940. Right? So what is n in this case? It's an octagon, octopus, right? 8. So therefore the sum of all the angles is 8 minus 2 times 180, or 6 times 180, which is 1080. We know that the sum of all the 7 other angles is 940, right? So 940 plus x equals 1080. We subtract the 940, we get 140. Okay. So that's that. There's some other examples in your book. In fact, I'll just put them up, and then I'll just give you the answers. And if you don't want the answers, pause and work through it yourself. So there's one, or number 6. And I'll give you the answers to number 7 and number 8 as well. Hopefully you can work through these. If you have any questions, we can go over those later. Okay, the other part I want to go through, we need a few definitions first. The first is an exterior angle, and we've covered the interior angles, right? So we talked about the inside angles here. An exterior angle is not this whole thing. Some people think, oh, that means it's the whole angle here. No, no, no. As it turns out, exterior angles are if we take one of these sides, just one, and we make a ray, so it goes forever. It's the linear pair right there. That makes an exterior angle. So this is an exterior angle to this angle there. That makes these two what are called remote interior angles. So remote being like far away, right? We live in Alaska. It's a remote place. It's far away from things. So these angles are remote relative to this exterior angle. And so the property with these guys is pretty easy to derive. Here's my setup. I'm going to say angle 1 plus angle 2 plus angle 3 equals what? What's that equal? 180, right? But guess what else equals 180? Angle 3 plus angle 4, right? That's the linear pair theorem. So that's equal to 180. So since these both equal 180, I can set them equal to each other. What property is that? Well, that's the transitive property. Angle 3 plus angle 4. Cool. Angle 3 is in there twice. Let's subtract it off. Subtraction property of equality. That leaves me with angle 1 plus angle 2 equals angle 4. And this makes sense. We know that angle 4 is supplementary with angle 3, and angle 1 and 2 add up with 3 to make 180, so they're kind of supplementary as well. So as it turns out, angle 4 here is equal to the sum of 1 and 2. Right? Should be kind of common sense, but we have a theorem for it. It's called the exterior angle theorem. We'll do a couple examples. Part A here asks us to find angle B, and this is a real similar setup to what we had before. We have this angle here is equal to the sum of these two angles. I drew it big so you can see the text. The values they give for these two angles are 5z minus 2 and 2z, so I know that 2z plus 5z minus 2 equals 145. That's how we get this. 2z plus 5z is 7z. Add 2 to both sides gives you 147 divided by 7 gives you 21. So z equals 21. And then you just plug z back in to find it. See if you can do part B. Go ahead and pause here. And then I'm going to simply get rid of these so you guys can see the answers. You should have gotten x equals 50 and an angle of 142 degrees. But same sort of deal here. We know this one's 90. We know 90 plus x plus 2 equals 3x minus 8. And then it just becomes an algebra problem at that point. Okay, 2 more real quick. Try number 11 and number 12. So pause here. Number 11, again, 63 plus 3x plus 7 equals 5x plus 50. we can solve for x, we get x equals 10, and then plug that back in. This one over here is a little trickier. It says if the exterior angle drawn measures 150 degrees, so we have that, and the measure of d is twice that of e. So for this one, we have to come up with our own variable. We can just pick that. We can say, okay, this is x. Therefore, if this is x, d is what? It says it's twice of e, so that's 2x. So we get x plus 2x equals 150. Solve for x, you should get x equals 50. Okay. That's it. That's all I got. Have a good one.